All right, here we go with Charles' Law. You might want to write this down at the top of your page because this is something any gas law that has temperature, you got to use Kelvin, which is why we spent the time the first couple days making sure you know how to do that. So you might want to write that down. All right, so here's your equation, Charles' Law, V1 over T1 equals V2 over T2. And we're going to do problem number 4 together. So it says a large balloon contains, underline because it's something I'm given, 5.00 liters of carbon dioxide at 27 degrees Celsius. Determine the actual volume of CO2 under standard conditions. Assume pressure remains constant. That just means you can ignore pressure, which we are anyway because there's no pressure in this formula. But it says under standard conditions. So remember, standard conditions, STP, means 0 degrees Celsius and 1 atmosphere. For this problem, this doesn't matter because it says assume pressure remains constant. So we don't need that part. When we keep it here anyway, we're going to need this part because that tells us our temperature. So just like we did with the Boyle's problems, catalog what you have. So V1, T1. So that's what you started with. And then V2, T2 is the change. So again, what did we start with? Well, 5 liters at 27 degrees Celsius. So 5 liters, 27 degrees Celsius. And it says determine the volume. So there's our question mark. Under standard conditions. Well, standard conditions tells us a temperature and a pressure. Again, the pressure doesn't matter for this one because we don't need it. You're not going to need it for any of these because pressure isn't part of this equation. So we can get our temperature from here. Standard temperature is 0 degrees Celsius. So we got everything we need to solve for this. The only thing we have to do is, again, make sure you convert to Kelvin. So when you convert from Celsius to Kelvin, you just add 273. Add 273. And you get, for this one, right, 27 plus 273, you get 300. 300 Kelvin. And for this one, 0 plus 273, you get 273 Kelvin. So there's your kelvins, there's your liters. Now we can plug in V1 on the top, right? V1 on the top, which is 5 liters. T1 on the bottom, which again use the Kelvin, 300 Kelvin, equals V2 on the top is our X, and then 273 on the bottom. So all you got to do is cross multiply and then solve. So when we cross multiply here, we get 5 times 273. So I'm going to try and fit it over here. 5 liters times 273 Kelvin equals, and for this one we got 300 times V2. So 300 Kelvin, running out of space, but I'll squeeze it in, V2. And now solve for V2. So it's not alone, so get rid of that by dividing 300 Kelvin. Divide this side too. Sorry, the heater just kicked on if you can hear that noise. Divide that side. If you divide this side, you got to divide over here. So there's your answer. Just put that in your calculator. 5 times 273 divided by 300. You get 4.55 equals V2. And then you need your unit. Well, look what happens to your kelvins. They cancel out, so you're left with liters. So 4.55 liters is your answer to this one. All right. So if you guys have questions, just email me, and you guys again are going to do the bottom 2 on your own.